Okay, I'm going to wrap up a couple things you guys have been actually doing all week and maybe thinking about or maybe not thinking about. We're kind of just, I'm going to touch on a couple general reproducible research concepts and then talk about environments and containers so you can work in the CryoCloud, so you know a little bit more about how CryoCloud's working, and so you can spin up your own as you like. I just want to remind everybody, the whole point of this is not to punish you for daring to be a scientist. It is to make you a happy scientist. And look at all that ocean data everybody was working with. Okay, there are a lot of levels to reproducible research. And from very simple things you can do to make yourself happier in 6 months or collaborators to fairly complex operations. At the simplest, this is just sharing your data in code, to documentation on code, documented data, and then we move into the reproducible environments so people can actually recreate your work and build on it. At the very most basic, you guys, now everybody's committed to doing this and has been doing it all week, is just using Git. And I just want to remind you, as you're doing this every day, you can push quite often. Actually, you probably will be much happier when you needed to go fix a bug or you've crashed your whole workflow if you're pushing often. And I like to push every single time I finish a fix or a feature. And you want to keep your commits small and coherent, small and cohesive. Okay, another most basic thing is turning stable code into classes and functions. Now, during the hack week, you may or may not have time to actually do this. But this might be as simple as, you have a whole pre-processing routine for some CSV you read in. First, in your Jupyter notebook, maybe you just turn it into a nice clean function that you can reuse. And from there, you might want to actually put it into like a util script that you can just import. And then really probably most important for posterity and for yourself, 18 months down the line, is documenting your code, sharing your data. Okay, beyond these real basics, creating a reproducible environment, which we've been doing all week with CryoCloud. The Python ecosystem is pretty complicated, and there are many tools that have pretty hairy requirements that can be quite challenging to install. How many people have actually installed, let's say, Xarray on a raw Python on your system? Okay. How about GDAL? Have you guys ever tried to install GDAL just from scratch? It's really painful. And then you try to recreate some functions you had that were in the previous version of GDAL. It's a huge headache. I mean, it really halts science. And a lot of these tools, that's the case. They have requirements in C or C++ or Fortran sometimes that are really challenging. And so that's kind of what sparked a lot of this, a lot of the movement over the last 5 years, the last decade. They can be really hard to coding environments, particularly in Python. And because Python's so flexible and allows so many modules, unlike MATLAB, it makes it really challenging to build some environments from scratch. Packages change over time. Maybe a function you really needed, or the way you were using a function, has changed in a new version. So you might want some version control of your environment. And this can lead to huge headaches, particularly if you're using sort of cutting-edge packages. Let's say some machine learning packages that are under development can be really challenging, especially if they require the GPU. And locally, I think some of you guys said you were actually, on the first day, we're actually using Python on your local machine without any type of environment. And sometimes you can actually trash your computer that way because many system utilities use that base Python install. So we put it in a sandbox. And there are different kinds of sandboxes, different containers, and virtual environments. Some examples you might have seen in the wild. Who's heard of venv? Stands for virtual environment. This is a Python only, like a native Python virtual environment tool. I'm not actually going to talk about that, but it is nice if you're testing something really simple and you're just doing it locally. How many folks have heard of Conda? Okay, great. So Conda creates virtual environments at the Python level. And there are a lot of pros to this. Not just environment isolation to protect your system and to protect different projects from each other. It's super well supported. There are a lot of prepackaged Python Conda environments, like the sort of de facto Anaconda. And it's a really extensive scientific computing ecosystem that'll fill most of your needs. It also handles dependencies well. Installing like some geospatial libraries with this can take minutes as opposed to, I mean, I've spent days installing GDAL on some machines. And it's mostly cross-platform capable. So your exact same Conda environment will almost certainly work across Mac, PC, Linux, and even on a lot of embedded systems. OK, so first off, I'm not going to have everybody do this with me just for the sake of time. Oh, we're doing pretty well on time. But I'm just going to build a simple Conda environment just to show you what this looks like. So this is a environment.yaml file that's going to build a Conda environment called simple geoenv. It's going to use the Conda Forge channel, which I'll sort of let folks look this up afterwards. But this is the channel, basically the repository where all these packages are stored. And then all I'm going to install is Python 3.10, NumPy, Pandas, and X-Ray. And I'm going to specify exactly which version I'm using. And so if I pull this in, if I just open up the terminal, can you guys see? OK, how about OK, well, I can't go too much bigger than that and keep it here. I'm just on my local machine, yes. And all I'm going to run is this Conda environment create. So if I just go here, and let me show you where I am. So all I have where I am, I'm just in a directory on my machine, and I have this already here. So if I just look at what's there, it's exactly what I just described. So it's just those packages.
Wait, so how do you create environment YML in the first place?
It's just a text file that I made in Sublime. So so this is just, well, I'll open it for you. Yeah, and I just looked up which versions I wanted, and just wrote it like this. And the formatting, there's no special formatting. Oh, I realize you probably can't see that super well. And that's all that it is.
And then that file will automatically update as you install?
Nope, this won't update or anything. This is the template that I'm going to use, the spec file that I'm going to use to build my environment. So what I'm telling Conda is that I want an environment with this name, and this is all I want it to have. So I'm saying install exactly these things. And so if you and I were working on a project together, I could give you this file. You could just run it in this same command, and you would have the exact same Python environment as me.
I see. But then if you installed something, it wouldn't change that environment.
Right. But what you can do once you have, let's say you install some new packages, you can export the YAML file that describes your environment, and you could hand that to me, and I could rebuild that exactly. A YAML file just means, what does it stand for?
Yet another markup language?
Yet another markup language, yeah. Basically, it's just a human readable, easy format for some of these spec files. And so I don't know if you saw that. It's hidden there. But basically, it was just installing everything, all the dependencies of these three libraries. It was installing all the binaries needed. So now we have this fully fledged environment. And what you're going to see is, you see currently I have this base. It says base here because I'm already running Conda. So I have it installed on my computer. It's just like an executable you can download and run. What does Siri think I'm doing? And then all you have to do is just run this activate command. And there's a lot of good documentation for this. And now, if I just go into Python, I have all those libraries that I wanted. So I can import pandas and do whatever I need. And this is a nice, simple way to share an exact spec for the environment that you want. It won't change over time. As long as these versions are hosted, which they should be indefinitely, you can go and rebuild an exact environment and share it. Any questions on that?
I have a question about a company.
Yeah, go ahead.
So when I was more naive, I also installed stuff outside of the Conda environment.
Okay.
Like you heard other people have that as well,
Yeah.
which now sometimes causes conflicts.
Yes.
So is there a good way to reset that? You have to just uninstall everything?
Actually, I'm not sure the best way to do that. So you're saying on your like native Python. Well, are your conflicts when you just try to run other things in Python, or are they like your actual applications aren't working?
Sometimes when so what happens is for people, if this happens to you, if you have stuff installed on your base computer, it can sometimes conflict with the Conda environments you make then. Because then the Conda environments still see what's on your base.
That's depends on how you set up your Yeah. I think you can specify that they're fully separate and don't pull from any of the base that you have.
This won't cause that problem, right? So those installed in Python.
Right, right. So this is a fully separate. Go ahead.
I'm quite frustrated with Python.
Okay.
Because we can install that from brew install, we can get conda, we can have monplat,
Yes.
and then sometimes it just doesn't work at all. And like sometimes it works in the Python environment, and we launch Jupyter Lab, it doesn't work at all. And I'm trying to install package from pip install Python -n.
So the goal of this is the goal of what I'm showing here is to prevent people from having these headaches. Basically, yes, if you're installing it from Brew on a Mac and from all these other things, you're going to have conflicts and it's going to be challenging. But I mean, frankly, like go ahead, Ian. Yeah. Yeah. And a lot of these solutions are much more mature now than they were 5 or 7 years ago, and so they're more of solved problems now. I won't say they're 100% solved, but much more so, because it is a pain. Go ahead.
Right, so you've done this.
Yeah.
And then you want to open your Jupyter
Uh-huh.
Lab or your Jupyter Hub notebooks. How do you make sure you're getting this?
So yes. So if you're running Conda on your machine, you would have to specify Jupyter as another thing that's installed in this Conda environment, because Jupyter Lab is a.
Yeah. So I guess I have Anaconda.
Okay.
Which is similar to that, right?
Yes. It's confusing because Anaconda Inc. is both the company that builds and maintains a lot of these tools, and Anaconda is the default environment for scientific computing. But Anaconda, the environment within Conda, has all those packages that you want.
I need a diagram.
Yes. So I recommend, well, unless you have a reason, not using that, at least in this case. So you would just add another line that says Jupyter Lab, and you specify the version. You don't even have to, but I recommend specifying the version. And then when you're running Conda, and I haven't done this because I didn't install it, but you just run Jupyter Lab from the command line or from wherever, and it will only have access to this.
Okay. I think I got it.
But I have another solution for you if you don't like that.
Something better, yes.
I have, at the end of this, I'm going to give you some of the details, and I'm going to give you a one-line solution to 90% of these problems, or you can keep using CryoCloud. So some of the problems with Conda that actually were just alluded to are that it sometimes does confuse things with your system. There also are some packages that aren't fully system independent. They aren't fully cross-compatible. And maybe you have a package that has to be on a certain version of Ubuntu, or maybe it has to be on a certain, lightweight version of Linux or something like that. So Docker, which actually we've all been using all week under the hood, is a system for creating environments at the operating system level. And we're going to build a really simple Docker image and container in just a second. Basically, in the case, oh, sorry, I've been touching my mic. In the case of Docker, you have what's called a Docker file, which is a very short, simple text file that outlines the whole operating system you're going to build, the whole virtual machine, and everything you want on it. That creates an image, which is just simply a template for your VM. Think of it like the mold that you're just stamping out virtual machines with. And then what you stamp out, what you actually run in practice, is a Docker container. So that's a running virtual machine that you can run locally, that you can throw up on the cloud. You can deploy it into production and have tons of them running if you need some sort of distributed system. And why Docker? Environment isolation, again, just like before. It's really well supported. It's widely used across a lot of data science and computation. It's also much more portable even than Conda, because your whole OS is encapsulated. And again, ideally, in 10 years, if I have an image saved and Docker still exists, which we hope it does, in 10 years, 20 years, I could give you my exact OS. It doesn't matter that none of those packages are even available anymore. If I have the image still, I can share that with you. I mean, think about being able to run code like with just at the click of a button from the 80s. It'd be amazing sometimes. It might be horrible also, but. Okay, and it's really lightweight compared to other things you might have, like VMware, some of these other virtual machines that you might have used. Okay, what's the other one big reason for Docker that I haven't mentioned in this bullet point list?
Different operating system.
Well, that's a great point. It can be a one-liner. What's the big reason? Why are we here? What are we doing? Cloud. Okay, it makes it really easy to run your exact analysis. Oftentimes, the exact VM you're running locally on your own computer in the cloud. And there are a couple big reasons for this. The main one, actually, that we've been getting this week is the benefit of proximity to the data. So we're right next to the data. We've got a big pipe between our compute and our data, and it makes things much faster. Also, if you don't own, a $50,000 GPU machine, you can use one for a day, and at the cost of ones or tens of dollars, if you're cloud capable. Of course, based on Ian's talk, you could also spin up this whole DAS cluster on AWS. You could process an incredible amount of data if you're sort of cloud capable like this. Okay, and here, this is a Docker file. We're going to build a really simple entire virtual machine with an updated version of Python in a single line. So here, it's just this command, and I'll show you the Docker file here. So it's just exactly this one. All I'm doing is I'm pulling the oh, you can't really see this, huh? Okay. I'm pulling the latest version of Ubuntu, which if you're not familiar is just sort of a standard Linux distribution. And then I'm just updating the machine because even that might be a couple months old. And then I'm just installing Python 3.8 and pip, just in case we want more packages. Here they are. And I'm just going to say Docker build. I want to name it simple geo image because this is going to build me an image. This is my mold. Oh, I got to run Docker. So if you actually do this, you'll have to install the Docker desktop. Basically, this is like the factory that prints out the molds. And you can just download it from their website. That runs quite easily, and it's capable on pretty much any modern computer. So let's give that about 30 seconds. And any questions? How many people have made their own Docker image before? Okay. Cool. Okay, it should be running. And now what it's doing, I'll show you a bit more about this. It actually just pulled this. It just pulled the latest Ubuntu from the cloud. So this template was basically already built. All I had to do was just install Python, which was quite fast. And now I have a fully functioning template. And then the next command here, which is just all it's doing is just running it. And I'll describe this here. So it it's cut off a little bit, but I'm just saying run a container named simple geo container based on the image name simple geo image. And now I've got it. So this root is the terminal on this virtual machine that's running on my computer. And you could run Python in here. You can launch a Jupyter Lab from this. You can basically do anything that you don't need a full GUI for. So anything where you just want a VM, you have this whole sandbox now on your computer. And it's really lightweight. And within this Docker desktop here, you can decide how much memory it has from your local machine. You have full control over all of that. Yeah, go ahead.
In that file, so your little Docker image, is that where you have to put Python 3.8 and pip? Is that
Yep.
where you would install other Python?
Yes, exactly. So typically, I mean, feel free to say if your workflow is different, but my workflow here would be I would actually install Conda on this, and I would use Conda to safely install all the requirements and all of the dependencies that I need. And so here I would basically just have another run command that says, and actually there's a whole conda. You can basically download this that's already pre-installed on a image, and then you would just install all of that from there. Go ahead. Do they get big? They get into the gigs, yeah. I mean, if you have a ton of stuff on there, it could be 5 to 10 to 15. But like this, almost certain this full Ubuntu image is like 200 megs. Pretty lightweight. But then the one that, like Anna and I have a special image that runs this drone processing software Anna's led. And that's like, what, 5 gigs? It's pretty big because we have a lot of special geoprocessing tools in there.
They don't get much bigger than the like conda environments.
Yeah. It's similar. I mean, most of the bulk is Python and its dependencies. Yeah. Well,
I think I missed this. Is the name of this file just called Docker?
yes, no extension or anything. I mean, you can name it whatever you want as long as you, yeah, so actually what this is doing is it's saying, Docker, build an image named this, and look for the Docker file here. That's what the dot means. It says, you could name it whatever you want, but you'd have to specify it. But this just says, in the current directory, look for the Docker file.
So is there a special tag at the end?
If you had a different name, you would have to have a special tag, yeah.
And then where does this live?
Yes. Which part? The one I built or the one that I'm pulling from?
I guess both.
Okay, yeah. So I'll get to the registry part where you download it from. But this lives just locally on your machine. So, and actually, yeah, so if you build 10 of them, it might take up a lot of space, and you can clean them and remove them all. And there's quite nice, I don't have it up right now, but so let me get out of this machine. And in here,
Something that's stored
yeah.
in the Docker image, though, are the applications and whatnot. There's no, like, nothing you create, like notebooks or any of that.
Yes, that's a good point. So actually, I will talk about that in just a second. But okay, you're right. It is taking a little longer. I'm still going to try to meet my time limit. But what you can do is it's a VM. It's a virtual machine that's running on your machine. But you could treat it as if it's its own computer. And so what you do, you can mount like one of your drives. Like what I do is I mount my code and my data drive onto my VM. And then I have access to them as if they're on the virtual machine. And I'll show you a command that does all of this. But yes, exactly. There's nothing in the Docker, and it's not good practice to keep your data and code within this container. You want them to be ephemeral because you can, if you launch them in AWS, that instance itself, you want to be able to launch and kill as needed. Other questions? Okay. Oh yeah, go ahead, Brian.
If you don't have root privilege on your machine,
Yeah, you can. Oh yes, right. Without sudo, you can still have full access to the VM. Go ahead, Ian.
For those that work on government-issued computers, though, Docker itself requires root permissions to run.
Yes.
So there are
Yeah.
issues there.
Say that again. You need root permissions to run.
So, well, basically, when you install Docker, you need root to install it, and you kind of grant it permission to act as root on your machine. So
Right.
there are certain restrictions for people
Yeah.
on restricted computers.
Right.
Yeah, so Docker needs to do that.
Okay, but a big point that I want to make for let's say 80% of use cases, maybe 90, 95, is you often don't need to build your own image unless you have special requirements. Because brilliant folks like at CryoCloud and the Pangeo group have built very well fleshed out geospatial and earth science and scientific computing Docker images. So they have the molds already made. You can just stamp out your containers. For example, Ian built us a very nice image for this week. Whether you know it or not, you've been using this image the whole time. So every time, I have an image later. Every time you launch CryoCloud, you're actually pulling this image, and that's what you're running on. The one I use is quite similar. There's one from Pangeo that's updated every 6 months or so that I do 90% of my coding on, locally and in the cloud. And the beauty is these can then be run basically anywhere Docker is available. And on most cloud computing environments, it's available, and locally for most people. Go ahead.
So, because the Docker image is like used for sharing, is it hard to like update or change those
Well, these sort of, I don't want to call them industry standard, but these like base foundational Docker images, you would have to go through a process of requesting updates, which is fairly straightforward, but may take time. But once you're running in a container, it's very easy, just like some of you have been doing, to pip install or conda install from there. So like, and if that isn't a complex installation, you could just do that every time. Like you might have seen in Tasha's tutorial, she had some pip installs at the start of one of her notebooks. Yeah. Okay, so this is probably tiny, but just to show what I actually do for all of my local coding is run this command. Okay, which is here. I'll run it and then I'll describe what's there. So basically, I'm running a Docker container. Kim, to your question, I'm mounting. Too small? Yeah. Is that okay? Still probably not the best, but I'll zoom into each individual one. So Kim, I'm mounting my home directory into the image. So this is like the image side of the file directory. This is my computer side. So I'm basically giving it access to all of my code and all of my data. I'm saying I want it accessible over this port. And there's really good documentation for all this. I just kind of want to show what it's like to do a one-line command that runs all of this. I'm pulling this notebook from an online registry. And then I'm saying launch Jupyter Lab on this IP address. And if I go in here, it's all loading up. You can see all these Jupyter Lab commands that are running to get this started. And then it's going to give me, in about 10 seconds, a link to run on my local machine. Let me make sure I'm getting all of this. Yeah. With this, state-of-the-art image and access to all of my data and code. And this is where I do, if I'm doing local development, this is where I do all of it. And you can do this with any image that you want that's hosted somewhere. And it was already pulled down, actually, but that image was about 3 gigs or 4 gigs, I think. Questions on that?
If you're going to the cloud, you just have to use that link.
Oh, no, well, this is not in the cloud. This is
right,
just...
if you wanted to use this image, the
Uh-huh.
Docker image that you created, on a different environment.
So you would have to have some sort of Jupyter Hub accessible that had this installed, or you could install. Basically, I can specify this one. Like if we go to,
Yeah, can you share this on the hub?
yeah, and actually I have, this is in a couple slides, but let me shut down my, yeah, I have it here. I'll just go to where I have it. So it's the next slide. So good question. In here, every time you click on this, you're actually loading the one that Ian built. You're loading this. That's just the default. But if you wanted to, you could put your own in, and it would pull down that image and run it for you.
And you could put the Pangea one in here, right?
Exactly, yep. And the point I want to make is you guys have been doing this. Every time you log into CryoCloud, you're taking this image that's been built, you're turning it into a container, and you're running it through Jupyter Hub.
So just to clarify, when you build your Docker and you specify all the other dependencies that you want from Python, you then don't activate within the virtual machine, or is it already very Docker?
It's a good question. So she was asking if you have to conda activate if you've built a conda environment within Docker. You could, but you can actually have a line in the Docker file, basically, so every time it starts up, it does that for you. So you can run, like in the Docker file, you can tell this image, the mold, like a couple commands if you want to set specific stuff every time the container launches.
And then if you want to add packages that you didn't already install, you don't do the percent.
You can do that basically from the command line within the container, but because the container should be ephemeral, you would have to do it every time. Yeah. Or you could rebuild the image with the stuff you need. I also just kind of want to make the point, this is Amazon AWS West 2. This is where all our code has been running, where all our data is. Just to kind of like, it's the cloud, but it's this giant data center that I'm pretty sure is in Oregon or California or Washington. Yeah, in Oregon. And, this gnarly like outflow swamp and all this stuff. anyway, I mean, this is a place that just has computers running, and we just happen to have remote access to it. Yeah.
So can you put a MATLAB, because we have option listed, can you put MATLAB in the Docker?
Yeah. Yes. So because this is this virtual machine that's quite flexible, yeah, you would just have to bring your own license. Okay, I'm wrapping up here. I realize it still is complicated. There's a whole tool chain here. It is simplifying, but it's not dead simple at all. And the space is moving pretty fast. Like again, if you were playing around with some of this 5 years ago or 10 years ago, it has changed a lot. It has improved massively, but it's not simple. But the goal is to simplify your workflow. And it's really to enable you to be a better scientist. It's not to necessarily force you to become a cloud data engineer unless you want to. A lot of good, well-paying jobs if you want to. And I just want to sort of advocate, I guess you guys all have the experience now, but CryoCloud is an excellent example of simplifying this process. Like to just click and launch this. It's really beautiful. These are mostly for reference. This is sort of the NASA cloud ecosystem right now. I'm not going to go through these too much, but of course you have the DACs that often are stored outside of the cloud. You have all these capabilities within the cloud. I have a couple references at the end. This is actually, I just grabbed this from Tasha from 2i2c, but this is sort of the environment we're working in. Just in case you see these buzzwords, Jupyter Hub is actually like the server that's running on AWS that's allowing us to spawn these different containers. And there's major support for this. There's a lot of funding coming out. A lot of grants now have access for cloud credits, which I think, as Tasha said, it's quite smart, not necessarily to build your own environment. If you can pay them and do everything there, that'd be quite nice. And the real goal of this is, again, to put sort of the discovery and fun back into science through this fairly simple paradigm that has a complex tech stack to make it happen. I'm not going to touch these at all, except that if you just want to check out these slides, this is a really great tutorial on X-ray. I highly recommend, even if you're quite experienced, to just go through this. This is a really excellent class that Ryan Abernathy put together. He was one of the core developers on X-ray, an oceanography professor at Columbia, and a couple of references that I recommend you read. And from there, I'll say thanks and take any questions.
Access is really cool, but you do require internet access.
Yes.
To run it. So in a scenario where you don't have a native copy of Jupyter Hub in your laptop, and you run everything on the cloud, and let's say you want to go on an airplane that's 15 hours long, and you want to work on your load, what's the best practice for that scenario?
I'm happy to take other advice. I mean, I almost always do have a local version of the image. Of course, then maybe I don't have the data anymore. But I can hack on some little things. But it's a pretty light load. I'm able to do this from a plane if I pay for internet. There's no problem. I mean, because you're streaming such little data, it's as cheap as visiting a website. But yes, actually, the plane use case comes up a lot. and yeah, sometimes I'll pull down a little logic problem and like a dummy data set and hack on it if I'm not going to have internet for some reason. But yeah. Okay.
So the images you can run locally. So if you have Docker or Podman, for those of you at NOAA, you may have trouble getting IT to install Docker, but my experience will install Podman, and then you can run Docker run and the image name.
Right.
And you can run it locally, so you don't need internet. So you're going to have a browser, and you'll have the same environment. And you have to do a little bit of extra to get it to talk to your files on your computer, but people, like I know people who do that all the time because they don't want to install these complex environments, like installing GDOM could make you lose your hair.
Yeah, good question. Any other thoughts? Go ahead, Ian.
Since Eli just mentioned it, and maybe people didn't catch that, we've been saying Docker.
Yeah.
Docker formats are something called an open container initiative. It's an open spec for what these image files look like. And Docker is not the only player in this game. Podman is something that a lot of academics use. There used to be another one called Singularity, also used often in the academic community. Docker receives a lot of funding from the private sector, so like they're kind of all over the place. It works great. There are initiatives that all use this open container, the OCI format, Open Container Initiative, I think is what they call the format. So there is some flexibility there. Don't fear getting trapped into Docker as this big private entity.
And Conda now is mostly open source, even though there is sort of a company on the side of it. So these are both probably, these concepts and formats are probably around to stay.
And then just one other thing to ask, I'll ask this of you, Patrick. How would you compare the process of sharing? Say I want to curate an environment. How would you compare the process of sharing a Conda environment with your collaborators versus sharing a Docker image? Like, what is easier from your perspective in terms of like, I want to share with a collaborator and get them to do what I did?
Yeah, that's a good point. And I mentioned this, but maybe I didn't describe the concept super well, but it's so much easier to share a Docker container. A Docker image, I mean, Docker Hub is like, Anna and I have collaborated on some of this stuff. It's like, it's basically GitHub for the image. And sometimes Conda environments, especially if people haven't specified every version of every package, there can be weird conflicts. It can take a while to build. I mean, it solves the dependency graph that it solves. It's really complicated. And so the more packages you add in there, if they're not like locked in and perfectly working with it, it can take a while. Whereas Docker, you're sharing the whole image. It's not doing anything except sharing like a 3 gig file that person downloads and runs. So my experience sharing Docker images has been much smoother. Yeah.
Can you build a Docker image and run it on Windows and Mac?
Yeah, absolutely. Okay, feel free to find me, and I guess you guys have 45 minutes to polish and finish up. Good luck.